Yes, so good evening everyone. So welcome you in the 14th session of ROTW 2026. Now our esteemed speaker, Dr. Asim sir has joined. So now I'm going to start. It is my privilege to welcome you all this session. Today we are honored to have Dr. Asim sir. We are grateful to Dr. Asim sir for kindly accepting our invitation and sparing valuable time to share expertise with us. Now, with your permission, I would like to briefly introduce our speaker. Dr. Asim sir is an assistant professor in the Department of Electrical Engineering, National Institute of Technology, Patna. He obtained his BTech degree in electrical engineering from Zakir Hussain College of Engineering and Technology, Aligarh Muslim, 2008. Yeah, someone is unmuted. So please don't unmute. Yeah. Aligarh Muslim. He completed his M.Tech in Power System Engineering from National Institute of Technology, Patna in 2012. And he earned his PhD degree in Power Engineering from the Indian Institute of Technology, Kanpur in 2021. Dr. Asim has been actively involved in teaching, research, and academic activities at NIT Patna. He served as PG coordinator at National Institute of Technology, Patna from January 2025 to January 2026. Since January 2026, he has been serving as PhD coordinator at NIT Patna. He has made significant contribution to the research in the field of electrical power and energy system. As per his NIT Patna's profile, he has 24 research publications and 1 patent and is associated with 9 research scholars. His research works primarily focus on forecasting renewable power systems and energy management, with emphasis on addressing contemporary challenges related to renewable energy integration and efficient operation and management of power systems. We are indeed privileged to have such an accomplished academician and researcher with us today. On behalf of the organizing committee and participants, I extend a very warm welcome to you. Without taking much more your valuable time, now I request Dr. Asim sir to kindly deliver today's lecture. Thank you.
Uh, Thank
Yeah.
you. Thank you for the kind words. Am I audible to you all?
Yes, sir, you are audible, sir.
So I'm sharing the presentation.
Yes.
So I think the first slide or the welcome slide is like visible to you all.
Yeah, it is visible,
Yes,
sir.
and the second slide is also like visible. You are now seeing the
Yeah,
movement of
it
the.
is moving.
So
Yeah, it is.
thank you for the invitation. Today we will be like looking into how do we create like figures and how do we modify the existing figures and how to keep the figure formatting in line with the complete report layout or journal layout or book layout. So we will be like starting from the scratch, and then we will be like looking into how to take help of these now richly available AI tools and how to ease our burden. How can we like minimize our time and then just give more time on the research and then less time on these trivial issues. So the session layout will be like we will be actually briefly, very quickly, we will be looking into why do we actually need figure in our technical writing, what are the formats, and how do we insert the figure, what are the packages, whatever, or precisely what is the most important package that one must know that is to be used in LaTeX for creating or for modifying the figure, what are these floating or captions and referencing, how to associate these uh, features to a particular figure, how to actually align or how to place different figures, uh, or how to enable these sub-figure options. Then some layouts that can be looked into depending upon the results one is trying to present in a paper or a research article. Then we will be looking into, can we like draw a figure directly through LaTeX? Like there is a way of importing figure. We import some existing figure, or we import a figure that we create in some figure creating uh, software like Inkscape or Visio, and then we import those figure created in these things, and then import into the LaTeX environment. The other way around is to actually create a diagram directly into the LaTeX. So we will be looking into what is that fixed uh, environment. What is this PGF plot? Then PGF plot is we use PGF plot to directly plot uh, these results, our results into the LaTeX without importing it. And then we will be like concluding it how we can like use the help or take the help of these AI tools, uh, some smart way of just minimizing our or cut time which we actually invest in writing these research articles, how to minimize the time and rather be more efficient in writing these articles so far as time is concerned. And then we will look into, in between the slides, we will look into some small question answer, some small projects, and then we will be then still looking into how to solve that. What are the troubleshooting? What that certainly, if you are actually starting to work on LaTeX and doing these figure modifications and other stuff, then there will be some errors. How to actually go through those problems, that will be our concluding remark. So at the end of this session, this is like we will be like expecting to learn that can we like insert a new figure or resize the new figure which we have imported from other uh, platform into the LaTeX? Can we like rotate, crop, or control that the dimensions of the image, the orientation of the image, or the size of the? Can we like control these things? Can we like place figure at a particular location? Uh, Irrespective of the default location provided by the LaTeX? Can we like write a caption or cross-reference those figures because associated with the figure we write some technical document, and can we like refer those figure to the written material in the report? Again, the can we are we able to those place side by side figure or sub figures, or uh, can we like trace a figure based as per our requirement? Rather, we wish to place a figure in particular alignment, rotation, or structure. Are we able to actually do that? So, this one, and then can we draw the figure directly into the letter without importing from some other software? So what was our workflow? At the end of this session, we will be like questioning ourselves whether we are able to do all that or not. So this one is the basic flow diagram of playing around with the figures in LaTeX environment. So if we are having some external figure, so again, uh, not going into those uh, copyright problems or that we import a figure from any source. Okay, okay, we have to take care of those things so that it should not be owned, or if it is owned, then we need to cite that. So basically, we import a figure from somewhere, and then we use this graphics environment. In that graphics environment, we do all those sort of rotation, cropping, placement, using those some inbuilt command that is available with this graphics environment, and then we readjust those figures, we place multiple figures. Along with that, we can have a special package that directly draws figure into the LaTeX. And then we have like some in that package only we can have like methods of drawing the plots in LaTeX in that. So to start with, this graphics package is the most important package that needs to be uh, fed into our main text file in the preamble of our document that use package graphics, because after that only our main text file or the compiler will look into the associated syntax. Otherwise, it is going to give errors. If we are using include graphics code into our LaTeX file and you are not using use package graphics, then compiler is not going to understand actually this code. It is same way as we do in a normal coding. Every code, every script has its own environment where to make it understandable. So this is a particular way of writing where we are inserting a figure. We are inserting a figure, and we are saying that the width of the figure should be 0.8 of the text width. So if we are working on a single column, full page document, then what is the text width on the paper? What is the width over which the text will be laid out? Because there is like on our A4 page, we do not write from corner to corner. We do not actually print from corner to corner. There are some spaces that are left around the text. So the text document is going to measure the width of that text, and then on that width, it is going to allocate the figure size as 0.8 or 80% of the text width. And this figure is the name of the figure we are trying to uh, place in our report. So this actually include graphics can do what it can do is that it can insert images like this command, only writing like include graphics, and this figure is going to insert that command. It can resize it. So one of the way of resizing is that we are modifying the width of the figure. We can also modify the height. We can also modify both the height and then we will looking into what should we do, what is the most efficient way of handling this figure. Then we can also rotate this figure only through this command. Include graphic, we can rotate it and we can crop it. We will be looking into this. So this is actually like it is going for a single column file, for a single column file, and for a single figure. This command is uh, sufficient to handle like most of the general uh, uh, surgery we do on the figures. This will be like most of the time it will be sufficient, unless we are going into some specialized form of formatting. This will be like sufficient. Now comes the approach or type of figure we look into in the LaTeX file. So there are like uh, pixelated figures that are available. So they can be like in PNG or JPG, JPEG form. So these are like good for some uh, like we need to show. For example, like I work on forecasting, so like if I need to show the weather report or some contour of an area or something like, so I can show through it these pixelated figures. But like if I'm going to draw some flowcharts, if I'm going to draw some circuits, it is better to go for vector form of graphics, because the problem in these pixelated figure is that somehow if we zoom into this figure, then we go from a very clear picture to a very green form, like pixelated face form. So it gets blurred as we zoom into that figure. However, when our figure is a vector image, then no matter how zoom or how fine we go into the figure, we will not get the figure will not get pixelated. So again, like in most of our research articles, we draw these circuits, we draw some flowcharts, we draw some control processes, or we draw some signal flows. It is better to go for vector image than to use these PNG or JPG for, because at the end of our report, if someone is going to take a print, the vectors based image is going to be very clear in that research paper. It will appear very clear with respect to these pixelated images. So these are like ways. So everyone has its own use. So if you are going for a screenshot or diagram or some photograph, it is better to use those PNG, JPG. However, if you are going to draw some graphs or some workflows or some signal flows, then it is better to use these vector images. So that comes with what is your requirement and what actually do we need at the end of our work. So at the end of our work, the quality of the report as far as its presentation is concerned, that will like reflect how good you are, how good a presenter you are. So if uh, a particular researcher is taking these uh, figures, he is taking the screenshot of that figure, or if the figure is too small and he's wasting a large amount of space around its around the figure, that is he's keeping a large amount of white area, then ultimately when someone is going to take the printout of that article, he's going to see a very bad picture so far as the general layout of the paper is concerned. However, someone who has a hold of these commands, or who knows how to actually uh, keep the thing in a more presentable manner, the end result will be very good. The presentation aspect of your paper will be very good. So actually we need, because at the end of the day, every information has to be marketed. What sort of research we are doing, we have to market our research to the audience to get a visibility of our work. And it has to be like in a very nice and tidy manner. So not only we need to do a good research, we also need to present a good research. So overall layout should be like good, apart from like the general information which we are trying to pass through the research. General layout of the work should be also very clean and crisp. So a basic, or to start with what will be like the first step when we are going to insert or do or present a figure in our work. We will be using this graphics package. We already highlighted that this will be the most important package so far as the figure insertion and modification is concerned. Then we will be using this floating environment. Floating environment means that LaTeX is actually placing everything which is written between this begin figure and end figure into a place most optimized as per the understanding of the compiler. If you use this environment, begin figure and end figure, what happens in a normal report is that or some of the researchers, like, they write something, then they present the figure, and then they write something. They create a scenario, they feed in the details, and then they go into presenting some figure, and then they comment on the figure that. So this is the general layout. However, when we are working with this graphics environment, and when we are working with this, when we are placing this figure between this begin figure and end figure, what will happen that the compiler will actually place the figure based on based on the approach that the white space in the uh, white space in the report is minimized. So it will place the figure. It can place the figure on the top of the page, or on the bottom of the page, or in the middle of the page. But the objective will be to minimize those large amount of white spaces, which generally, or to minimize the page breaking of the final report. So after starting this begin figure, we go for is centering. So the objective is that we need to place the figure which we try to feed in the report in the center of our page, on the center of our text width. So what is the placement of the text width or the page width? On the center of that, we want to place our figure. That if it appears good, actually, we do not want to left align our figure or right align our figure. Rather, keep it at center. So this centering is actually doing that thing. And then what we are doing is that we are now actually inserting the figure, include graphics, and this is the example image. That means that it is the name of the file. There is a PNG file, there is a JPG file that is named as example dash image. Okay, and then we actually label that figure. So what because so there are like we work on like some control theory. So there is like DQ controller or so on the figure we have created, we actually write the caption that this is the decoupled D-axis and Q-axis control flow. Same in this case, there is a figure and we need to name that figure. So we that depends upon your or that depends upon the intelligence of the presenter that what sort of caption we want to give. That should be actually like convey some information so far as the figure is concerned. So the caption is like this is an example actually example figure. This is the name of that figure. This is the name of the PNG file or JPG file. This is what is written below the figure number one, example figure. And this is what the fourth one is the label. That means if I want to use this figure in my report, then I want to actually label. The position of the figure has to be identified by the compiler. So I am labeling that particular figure, and I must highlight this point that one of a good practice, because if in a normal report, in a normal paper, there will be lots of equation, there can be lots of equation, there can be lots of table, there can be lots of figure. So one way of labeling is that if you want to label a figure, start with fig, colon, and some associated label. This doesn't mean that this label is for figure, but if I am going to refer it, then in the back of mind, I will say, okay, this label is for figure. If I was working on some table, I will be writing like tab, colon, and some identifier. If I am working with some equation, I will be writing EQ, colon, and like power balance. If I am working with some, like in a microgrid, I am working with some power balance equation. The power generated should be equal to power demand. This is the power balance equation. So if I am writing that equation, I will be writing label EQ colon power balance. So in this figure, I am working with figure. So every figure, I will be writing figure colon example figure colon circuit figure colon uh, uh, main controller algorithm figure colon anything. So this will so when I am associating my uh, associating this figure into the text document, I will be using this refer. Then if you write this refer, there will be a list of what are the labels associated with. Then you can identify actually, okay, at this point, I am trying to refer a figure. Then I'm going to only look into fig colon identifiers and nothing else. So this is a very good, and I actually keep it like this way. If I am labeling a figure, I write fig colon this. If I am labeling a table, I write tab colon this. If I am labeling a circuit, if I am labeling an equation, I write EQ colon this. Okay. So this will be the minimum example. Actually, the previous example you cannot actually run it because there is no begin document and end document, which is a must for any LaTeX to be printable or rather executable. LaTeX file to be executable. So this is the minimum working example. Like actually, I will be highlighting this also. So every tech file will be starting with a document class. What is are you going to present your work in a elsewhere, so it will be different. Are you going to present your work in IEEE transaction, so it will be different. Or if it is a general report or general article, then document class will be article. If it is book, there will be like different thing. So in a normal article, we will be using document class article. We will be using again for because we are actually discussing on figures. So we will be using this view package graphics, and we will be using not everywhere, but since we are trying to get hold of some information, so we will be using minimum working example. MWE package is actually it has got some inbuilt figures, text, everything just for these sessions to be organized. What should I write actually if I am going to like if we are going to share some information on figure uh, modification or figure uh, placement or something, then there should be like some uh, packages available in LaTeX rather than writing those things. I import information from that package. So MW is a package where minimum working examples are available. So after that, we will now enter into the document. Begin document and end document, everything between begin document and end document is executed or printed in our PDF output of the LaTeX file. In that, I am starting with the figure. We will be looking into what is the meaning of this HTTP, but begin figure and end figure, this is if you remove this HTTP, this is a floating environment. Floating environment means the LaTeX is going to place your figure anywhere in the report. Anywhere in the report. The objective of the compiler will be to minimize the white space that is going to be created after the execution of the complete file. The greater objective of the compiler is that the, the end result might not suit you, but the objective of the compiler is to minimize the white spaces, the page breaks and white spaces that is going to be created in the at the end of the compilation. Centering the placement of the figure both in a text width mode or in a page width mode. Then we are using include graphics to insert the figure. Which figure? Example image. What should be the width of the figure? How wide should be the figure? The width of the figure should be 70% of the text width. So on the page, at the end of the compilation, what is the width of the text that is appearing on a particular sheet? Of that width, 70% will be the width of the figure at the end of executing this command. If we want to modify it, we want to keep it as 80%, we will be doing 0.8. If I want to keep it as 50%, 0.5 of the text width. And then associated with every figure, there should be a caption to make it understandable what this figure is referring to. So example, scientific figure is a typical caption which I have placed here. And then I need to label the figure because at the end, the practice is that if you are presenting a figure, you need to explain the figure somewhere in your report. So referring to that figure, there is a way of labeling the figure. So I label the figure again. If you look into this, since we are working for in the figure or we will be discussing on the figure. So I have labeled it as fig, comma example, fig, comma example 1, 2, 3, 4, anything, but it will be in a format that helps me understand what exactly is this. And then after the end of this end figure, I am now writing a statement that will be a part of my text in the report or in the article as shown in figure. And I want to refer to that particular figure, then a tilde backslash refer this figure example. It will refer to this figure. The figure can be referred automatically. So this is the statement. So when the PDF is printed, it will be shown as shown in figure. If this is the third figure in my report, it will be like figure 3. The figure can be reported automatically. And end document, everything will be like printed. Okay. So the master commands. In include graphics, there are different options that can be enabled apart from inserting a particular figure that is named here as file name. So we can have our different options. That options can modify the width of the file, height of the file, scale. scale of the file, angle, what is the uh, rotation of the file with respect to the main text. Is it along the main text? Is it 90 degree? That is means vertical to the main text, or is it inverted? Depending upon the angle, you can like have 30 degree also. You can have like 120 degree. The figure be aligned according to that angle. The angle will be measured along the text that is present. The 0 degree will be along the text. And if I want to trim some section or some side, there are like some white spaces. Suppose you try to import a figure from internet, and that figure has the placement of the figure is that it is a very compared to the complete figure, the actual information is it's on the extreme right, and there is a large amount of white spaces in the figure. So why should I actually uh, why shouldn't I actually trim this figure such that only the informative part is inserted into the LaTeX file? So you can trim, you can clip it, and then also you can also keep the aspect ratio same. So normally the figure that is imported from the internet, it has got its defined height and width. So it has got its defined aspect ratio, the ratio between the height and width. So now if you are going to modify the width of the figure, by default it is going to respect the aspect ratio. So if you are going to use zero point 0.7 times of the text width, the height will be accordingly adjusted. So, and if I modify both the height and the width, I am going to actually distort the figure. Most of the time it happens. So in order to keep the aspect ratio same as the original figure, I want to stretch in such a way that the aspect ratio is same. I will keep the aspect ratio same. So these are some of the options or handles that are available with include graphics command. So how do we actually use those things? Initially, we have discussed that if width is 0.8 of the text width, it is going to actually use the figure width will be what is the width of the text width? 80% of that will be the figure width. You can actually keep it as same also. The width of the figure will be like equal to the text width, or it will be equal to the line width, or you can also fix the width to a particular size, like 8 centimeter or 5 centimeter. These are like some of the ways of uh, modifying the width of the figure. And again, this depends upon your taste or how better you want to present your information into the article. I need to modify the width as 8 centimeter. I will be using width equals to 8 centimeter. I need to modify the height as 5 centimeter. I like using height equals 5 centimeter. If I need to modify both the height and the width, I need to modify it like width is 8 and height. But what happens is that there is a possibility of aspect ratio distortion when using both the width and the height. That can like damage the uh, presentability of the particular figure. It might get stretched along the width, or it might get stretched along the height. So it is better to keep the aspect ratio should be like kept uh, same. That means if I going to increase or if I going to modify the height, the width is accordingly modified such that the aspect ratio of the new image and the previous image or the extended image and the previous image remains same. Okay, so like this example, if the left hand side is our original figure, and I actually scaled it, like if I scaled it or stretched it, considering the uh, page orientation, page or text information, it can like be a better way. However, if I'm going to modify everything, this figure might get distorted, misaligned. So the objective is to present our information to figure in a better way rather than to just fill in the space in the article. So the greater objective is to be more presentable rather than filling the pages. So how does this scale feature? So we have looked into what is the weight, how to modify the height. How does this scale feature work? So if this is the left hand side is the scale one, that is means 100% size of the figure. That is that was imported from some other software, some internet. I have used some PNG or JPG file, and this is the original size of the figure. If I keep it as 70%, it will be like reduced in both height and width. The scale, this the middle figure is like 70% of the original, and if I keep like the scale is at 1.3, the figure is like stretched along the height and the width, such that the end figure is 30% more than the first figure. Uh, and now comes the some uh, best practices. So I have seen that most of the cases, and I also prefer this one, that width modification is widely used. Width is equals to zero point 0.8 times zero point 0.8, yeah, or 80% of the text width, which we have actually discussed uh, some previous slide. This the first one is like mostly used, whether to keep it as 80 centimeter or some percentage of this text width or line width. This one is like mostly used. This is the way of actually modifying or rotating the image. Angle is equals to 90 degrees. So angle is equals to 90 degrees. That means the orientation of the figure will be along the longer side of the. There, like if you look into the pages, A4 size pages, there is a short size, short end of the page that along which the text is written, and there is a long end of the page along which we staple our pages. So if the angle is 90 degree, that means the figure is along the longer side of the page, or rather it will be making a 90 degree with the text of the page. As simple as that. Uh, Again, we can like keep it as 0.90 degree, minus 90 degree, or plus 45 degree. The figure will be actually uh, oriented considering the zero axis to be along the text line. That will be more rotated along that. So why do we actually need this rotation? So there will be many a times that you need to actually rotate the figure in order to fit in or use the article or use the spaces in the article in a more intelligent way. Or there will be the size of the figure that is like if the figure is large and if you are not using it, then there will be there can be a possibility that your figure will be just running out of the pages, or you will be seeing like 60% of the figure and the rest of the figure is like out of this printed sheet. In that case, uh, we have also seen in books, textbooks also, that if you are seeing some con- uh, controller control flow diagrams, and if it is very lengthy, we see that it is printed making 90 degree or along the longer side of the page. That totally depends upon how good you want to present it or how important is the rotation as compared to the presentation of the report. If that is like needed, we are going for that, and if it is not needed, then we will be like keeping it as simple. However, for large figures, we might, because along the longer side we are having more spaces as compared to the shorter side of the page. Now comes the trimming and clipping. So for trimming, this script is actually uh, important. We need to know the precisely. We need to know how the compiler is going to identify the sides of the images. So if we are having image, the compiler starts with the left side of the image, then it looks into the bottom side of the image, then right side, and then top side. So if this is the way the compiler is going to identify the figure so far as trimming or clipping. That means if I want to clip the, I want to keep the image simple, but I only want to clip the right hand side of the image by like 1 centimeter. Then accordingly corresponding to this right, I need to place the number or the centimeter of the image that needs to be trimmed. The rest we need not modify it or keep it as 0 only. If I need to trim the top of the image by certain amount, then I need only to uh, place the number corresponding to the trimming length at this top place of the script. And if I need to trim it from everywhere, then accordingly we need to like place the number at every position. And but we need to actually know that if I need to trim left side more as compared to right side and top more than as compared to what, we need to judiciously place numbers. For that, we should know that the compiler is reading the image in the sequence of left, bottom, right, and top. This has to be actually like taken care of. So now if you look into the left hand side A, and if I need to trim the left hand side, bottom hand side, right hand side, and top hand side, however, I want to trim the right hand side, uh, or if I want to trim the three side, left, bottom, and right as 1 centimeter and top as 2 centimeter, then this is the script. Is everything okay? Okay. So if I need to modify the left hand side, right hand side, left, bottom, and right by 1 centimeter and top by 2 centimeter, this is the way of writing. So this 1 centimeter is for the, this 1 centimeter is for the left hand side of the image. This 1 centimeter is for the bottom side of the image, and this 1 centimeter is for the right side of the image, and this 2 centimeter is for the top side of the image. Okay, and then I am writing this clip. So my figure is now clipped 1 centimeter from the left, 1 centimeter from the bottom, 1 centimeter from the right, and 2 centimeter from the top. Okay. Can be like there is like some noise. Okay, so a very quick, just checking. Have we like get hold of our of the information which we have like discussed for the last 40 minutes? So the requirement is that we have inserted a figure into the text document, LaTeX document, and the requirement is that we need to use 70% of the text width to place our figure. We need to keep the aspect ratio same. We need to rotate the figure and crop 1 centimeter from the left. What should be our script? Can we like have the code if somebody want to share it? The objective is like 70% of the text. So we have discussed width should be 70% of the text width. Width is equals to 0.7 slash text width. Okay. Preserve, keep aspect ratio. That will like keeping the aspect ratio, the ratio of the width and the height. Rotate by 9. So angle should be 90 degree. It is going to keep the, it will rotate the angle by 90 degree. And if I am going to crop the figure by 1 centimeter from the left, it is like 1 centimeter 000. and if everything goes okay, this is our answer. Okay, width is like 0.7 centimeter, 70% of the text width. Aspect ratio is kept same. Angle is 90 degree thin. 1 centimeter because the left hand side is to be cropped. 1 centimeter, 000, and then clip. Okay. Now this happens most of the time. Like it will be happening. Like if I am not being very conservative, it will happen 100%. That you need to place the figure at a particular location, but LaTeX is like placing it somewhere else. So our goal was that we are writing some information, then we are placing the figure, and then we are writing some information. Our this was our expectation. But when the LaTeX, when the compiler compiled my text document, it happens that there was text and text, and at the end of the page we are seeing the figure. This happens because as already discussed in the starting, this begin figure and end figure is a floating environment. That means that figure is floating in the complete document. The LaTeX is going to place it at anywhere. So there is a way of like forcing the LaTeX to place the figure at a very precise location. This is going to disturb the compilation process. There might happen that you will see some page breaks, some new pages, some extra white spaces. But then accordingly, you have to readjust your thing to come to a compromising position such that your text figure and text approach is also respected, and the white spaces in the generated PDF is also minimum. So, in order to like place or just uh, request the compiler, this small letter HTTP and exclamation mark, these are like a request to the compiler that if it is possible, please place the figure here for H. Please place the figure at the top of the page P. Please place the figure at the bottom of the page B. Or please actually the P is for like float in the page, and then this exclamation remark in the option is to relax some constraints. Like there will be if if it is not able to do that, then okay, there's no hard and fast that you need to place your that figure at a particular location. Now comes the difference between small h and capital H. If I am rigid that no, compiler has to keep the figure at a particular location, then capital H can be used. Okay. For that, we need to actually use a package that is called float package, because then only compiler is going to understand this capital H. These small HTTP and exclamation are associated with the graphics package. So the difference, okay, there it may happen that uh, when you are using this graphics package and then you are using this HTTP, it may happen that the figure is placed at a position that was not desirable. You do not desire that. But if I keep it as capital H, there will be an error, because most of the time you need to use this package of float. If I'm going to use this capital H, we need to ensure that in the preamble we are using this use package float. Now the compiler is forced. It is forced by this command to keep the figure at that very particular place where I have written or where I have written this begin figure capital H. So, but associated with this command, uh, it happens that if I am
ठीक है
yes,
ठीक है दो दो रोटी बनाए आ,
if I am using this capital H quite a lot, there will be like very poor page breaks. There will be like uh, uh, empty spaces present in the. So it should not be that every now and then I am using capital H. For some figure, if it is very critical, use capital H. Else go for a small h. Okay. So good captions. That means if now that we have inserted figure, uh, naming that figure is another important thing that reflects how uh, good a presenter you are, or we are, rather we are, how good a presenter we are. So for a figure, if we write it as caption as figure of system, rather than writing as the figure block diagram of the proposed load frequency control strategy for the interconnected micro. So the right hand side, it actually conveys more information as compared to the, no doubt it is a lengthy caption, and lengthy caption is again not a very good thing. The caption should not be too much lengthy because that is not that part of the actual continuous part of the text. It should be sufficient lengthy that conveys a majority of the information rather than very small, such as figure of systems. A very generic type of caption is that. So a useful caption should actually like it should answer these questions. What is shown in this figure? The caption should be written in such a way that it somehow reflects a presenter need not go into the article to actually understand that figure. Rather, the caption is sufficient to make him understand or what sort of system or what sort of experiment has been done of which this figure is the result, or what condition or comparison is done of which this is the result. What should the reader notice in complete if the figure is there? What actually can the reader extract from it should be actually given in the caption. So there are ways. We have actually looked into these things that we have actually passed the caption and labeled the caption, and then we have used in the text. We have seen this part. Now comes you have seen actually in these uh, books that are published by Springers that at some in the PDF format available online, you will see that there is the text written in the article or the chapter, and then you will see the figure 3 is shown in blue, and if you click, it goes to that figure number 3. In the text, it is so this is called as clickable reference. That means if you are working, if you are working on some article and you see, or if I actually I'm presenting some work and I want that uh, in the article, if the reader wants for the help of reader, what I have done is that everywhere I have made the uh, reference as clickable, then it actually helps him understand that if he is reading the complete article and if he comes at as somewhere written as figure 2, and if figure 2 is not very close to that text, and if you have actually then used this clickable reference, then the reader click on that figure 2, he or she will directly go to that figure 2. Okay. So for that, for using this clickable reference, we need to use this hyperref, use package hyperref. So this is one of the way of doing that. And then this is again for referring or for referring this clickable references, auto ref. And then I am referring to this uh, figure microgrid. I am talking about microgrid, and this figure is my way of identifying that I am talking about this. I am talking for a figure that is labeled as microgrid. Now comes this sizing. We have discussed it. What should be so one of the acceptable or again like some tricks you always keep under your sleeve is that while working with figure, the width equals to text width or width equals to line width is a better way rather than modifying the width and the height. Keeping the figure in the center of the page or center of the text is a better way rather than aligning the figure to the left or bottom or somewhere in the page. Keeping it as center, it visually it is pleasing. And then comes this H space and V space. H space and V spaces are generally used to fill in or increase the. So H space, that is certainly means the horizontal space. I need to increase the horizontal space between the text, between the figure. If I want to increase, then I will be using H space. If I want to increase or modify, both increase and decrease. See, if it is 1 centimeter, it is going to increase. If it is minus 1 centimeter, it is going to decrease. If I'm going to modify this vertical space, I'm going to use it V space. And a positive value is going to increase the vertical space between the text or between text and figure or between figures. And if I'm going to decrease the vertical space, I'm going to use V space with a minus number. And then increasing that minus will depend upon how large I'm going to decrease the space. So -1 is going to decrease less as compared to -5 or -2. So moreover, there are some other features as horizontal fill, relative weight, appropriate. So these are like some of the ways of using the space of the article in a very appropriate way. Now comes if I am using two figures and I want to place that figure uh, side by side. So one of the way is to start with, I start with begin figure. Again, this begin figure and end figure is is a floating environment. That means everything written between this begin figure and end figure will be placed anywhere in the article. After that, I am using centering. So what it will do is that what sort of thing that is written between begin figure and end figure, the complete thing will be at the center of the page. After that, what I'm doing, I am using a mini page environment. So mini page environment, this mini page is going to create a small page that will not be visible or a space uh, that is less than 50% of the page. That means what I am ultimately doing is that inside the figure, I am splitting the space into two halves. Of that two half, I am going to use slightly less than two half of the space point. That means 48% of the space. And in the next 48% of the space, I am going to use some another thing. So in the left half, this the highlighted part, the mini page that is slightly less than 50% in the text width. I am using figure one and I am using the complete line width, that means 50% of the page, complete line width, that means associated with this mini page, I am using the complete space, that means half of the, or slightly less than half of the text width. I have inserted this and then I have closed this mini space. So the end result will be there will be a figure one, that will be placed on left hand side of the page. There will be another figure if I am going to write this part of the script. In the similar way, there will be another figure number 2, that will be on the right hand side of the page. In this way, there will be two figures, figure number 1 on left and figure number 2 on right. So this is like side by side figures through use of mini pages. Okay. Another approach of using or presenting this side by side figure. So there is like in the previous one, there will be two figure numbers. Here, there will be single figure. So in this, the other way of doing this is using sub caption. So sub captions does is that in the previous one, this approach we can have only one caption that will be associated with the figure. However, if I need to highlight figure one as different caption and figure two as different caption, that can like happens in if I'm going to present two cases or if I'm going to present a result of two controllers, two different controllers, some linear controllers, some non-linear controllers, and the left hand side is for the result of a linear controller, right hand side is the result of a non-linear controller, and I want to present those results in a different figure, then I can use this and I can also use the caption. What I'm doing for multiple captions, I need to go for sub caption packages. After that, I can work in sub figure environment. So what I'm doing is that I am using begin sub figure and what space I am going to use 48%. So why I am not using 50%? Because at the end, when you are going to compile, it will say that your figure has overfilled the page. Just to avoid this, I am using the space that is slightly less than 50%, and then I'm using centering. I want to place my figure that I want to present in the article in the center of the half of the page. So I'm using centering, and then I am using or inserting this figure one using this include graphics. I am associating a caption and label, and then I am closing this subfigure. After that, I am using this H fill command. There happens a time that if the figure is too small, so there will be like very. If, what I am doing is that through H fill, it is actually using the extra spaces that is available after presenting the figure in between the two figures in such a way that the overall figure appears very symmetric. There is a figure, there is some space, and there is some side by side figure. Rather than placing two figure very close and keeping the space on the either left side or on the right side, it is better to place figure side by side and using the space between the two figures. The hfill command is doing that. So this is like complete sub-figure approach, which we have actually looked into detail just in the previous slide. These are like complete figure layout options or ways of presenting results that will depend upon what is your requirement and how do you actually need to present your figure. There can be like single and there will be two side by side figure and there is like third figure. So it can be in any way. There are like four figures in a 2x2. There is a large figure that is using the complete width, text width, and there is like two small figures. These are like in same environment, same figure, begin and end figure, floating environment. Large figure and two small figure below that large figure, taking 50% of the space. So three figure layout is this sub-figure environment. So I am again see the complete text width is split into three parts. So if I perfectly divide it, it will be 33.33% of the text width each sub-figure. I am going to take slightly less than just to avoid this overfilling of the figure. I am taking 32% of the text width for first figure, 32% of the text width for second figure, and 32% of text for third figure. That means there will be three figures in a row on a complete text. This again depend upon like requirements which I have highlighted here. If there are like three controller or three operating conditions or three experiments or three simulations, I want to present in a single line just for the reader to make a very intelligent conclusion or just to make my result more presentable, I can go for this figure layout. Or if I am having like four scenarios, I can go for 2 cross 2. Like there are two results on the first row and there are two results on the second row and there are two columns overall. Or if we are having some main result that is very important, that is highlighted in a, or that is taking the full text width, and there are like two more figures that is not that important as main result, but what are important, then I can like split the complete page into two parts and then use as A and B, figures as A and B. Okay, this is called
Hello, sir.
yes,
Hello, sir. Sir,
yes,
that, do you have any code that for 2 into 2 and that main figure and two large small figure code?
yes, yes,
Sir, PPT number 33 and 34, sir. Sir, is there any
yes,
code for this four figure in one place,
yes,
sir?
we can actually. So what? Then how to actually insert this figure A and B? So what I will be doing is that we will be going for sub caption environment. For in sub caption, I have not got the code for that one. But how I will be presenting is that for controller A and B, for controller A and B, I will be using 50% of the text width, or rather slightly less than 50% of the text width, or I will be using this begin figure as this is going to present my A and B part, this part, A and B,
Okay.
begin sub figure 0.48, and after that, I will be using another sub figure environment as 0.48 and 0.48. This is going to give me figure C and D.
So then four sub figure are in one command program, sir.
Yes, yes, yes.
Four sub
So
figure.
I will be four. There are four figures. So sub environment will be like four. There will be four sub figure environment.
Okay.
Okay, and everyone will be using this 0.48. This 0.48 text width will be used. Everyone will be. Okay, and I will be using depending upon. We can use some spaces. This H fill. This H fill. Apart from this H will be used between two figures A and B. Just actually, H fill is like this is giving me a space between these two. It will be
Yes.
using all the available space that is to the left and right and placing every space between these figures. After that, I will be using some vertical space to split my figure AB from C and D. I will be using this command, vertical space, and certain amount of space I will be giving after this after this subfigure or caption. I will be using V space, some space I will be giving, and then I will be writing this complete two codes of subfigure.
Okay.
Okay, so I will be using this vertical space to create this space. This space will be created. This space will be created by using V space. This space, and this space is created by H fill, horizontal fill.
Okay.
So if I use this, okay, in the same way, what I will be using is in the main result, I will be using width as text width, subfigure 1, width as text width. In the second, I will be using some vertical space for zoom A. Yes, I will be using 48% of the text width just to avoid overfill. And zoom 2, I will be then I will be using H fill, and then I will be using subfigure 48% of the text width.
Okay. Okay, sir. Thank you, sir.
So for rotating, we have seen how if the figure is very large, then we can have the rotation of the figure such that more details fit into the page. there are ways of creating figure. If we do not want to, if I do not want to import figure from some other place, can I like directly draw the figure? For example, if I am going to create some assignment questions or some question paper for circuit theory, and I want to for a, for basic electrical, I want to create a question, and then I do not want to copy question from any book. I want to have my own circuits. I want to make a new question for the student. So there are ways that I can like draw circuit precisely into LaTeX. That can be done through using this TIGS command. So TIGS command is actually very handy when it comes to drawing block diagrams, flow chart, control diagrams, circuit diagrams, these powered microstructures, everything like that particular electrical engineer or an engineer is associated with. Most of the figures can be like drawn. So for that, if I want to use this TIGS environment, we need to use this package TIKZ TIGS. And suppose I want to draw a rectangle, and in the rectangle I want to actually write controller. So how I can draw a rectangle? So in the previous, we were trying to import a figure. So a floating environment was created using begin figure and end figure. In this, we are creating a floating environment as TIGS picture, begin TIGS picture and end TIGS picture. And what I am doing is that I am starting with the 0, 0. What is 0, 0? 0, 0 is the left lower bottom of the rectangle. Left lower bottom of the rectangle is the 0, 0 node or point. And I am starting with this, and I'm saying that draw 2 unit of length and 1 unit of breadth. Draw a rectangle for that. So it will like draw a rectangle. So I have actually created a rectangle in a very simple way where I have got the length of the rectangle as 2 units and width of the rectangle as or breadth of the rectangle as 1 unit. How to actually write this word controller? I am identifying a point 1, 0.5. So where is this 1? So this is 0. This is 0. This is so this works in the same way as we have seen in Cartesian coordinate system. This is 0, 0. This point is 0, 0. This point is 2, 0 because the length is 2 and it is on the x-axis. This is 2, 0. This point is 0, 1. 1, why? Because the breadth is 1. This is 0, 1. And this point is 2, 1. I need to write controller at a place that I want it to be. So you can write it in anywhere, even you can write it outside this rectangle. But normally what we do is that we create a block and write information in the center of that block. In the center of it. This is like the most general practice. So what we are doing, we are identifying a point. Which point we are identifying? 1, 0.5. So if you precisely look at this point, this is the center of the rectangle. So 1 is the half of the length of the rectangle and 0.5 is the half of the width of the rectangle. At the center of the point, I am writing controller. So it is like centering the information as per the size of the rectangle. Okay. So in a very simple way, I have drawn a rectangle. I have write controller at this. So this is a very simple way, but again, like we can draw a flow diagram. If it consists of rectangles, a bunch of rectangles, we can draw a flow diagram. We can draw block diagrams if it contains a bunch of rectangles. So apart from that, we need to some like so far as block diagram or signal flow diagram is concerned, we need to have some summers or other thing also. We have some arrows. We have some plus and minus sign. There are other things associated with the block diagram, but one thing for sure we can do is that we can draw a rectangle and write something in the center of that rectangle. If I want to write an information just above this line, can we write it? Certainly we can write it. What I will be doing is, this is the this is 0 1 point. I want to write above this. So what I will be doing is 1 comma 1. 1 comma 1 is this line, slightly above this. 1 comma 1.1 is going to write, or 1 comma 1.2 is going to write at this place. If you are able to see, I'm trying to actually uh, hover the mouse over this space. Okay. Next come uh, the normal flow diagram. So what we are doing is that there are ways of minimizing the effort. If if somehow if somehow we need to draw rectangle of a particular size, if somehow we need to draw a rectangle of particular, we can identify or we can highlight in the very beginning that our rectangle has to be of particular size. It should be like minimum width of 2.5 and minimum height of 1. We have identified it. We can also draw a rectangle of different size. What we are doing is, we are identifying a node, we are identifying a block, we are writing this block as input, and then we are identifying a node, we are drawing a block. These are blocks. These are blocks of which we are writing input into the block. Okay. This is the block of which we are writing controller. We are identifying the controller as this. And the third block is known as the plant, and we are writing plant inside the block. Now we are drawing an arrow. So this uh, represents an arrow between what? Two blocks. Block that is associated with input and controller, and an arrow that is associated with controller and plant. So this is going to draw an arrow that is starting from input to the controller, and that is starting from the controller to the plant, and then we are closing it our figures. Okay, so this is a very simple way. Now most of the time we draw these flow diagrams, PV array to DC converter to DC link to D. So this is like, again, uh, this is not going in the horizontal way, rather this is going in the vertical way, but it can be like drawn. Now comes the PGF plot. If I need to draw some graph, this is the uh, this is one of the way of presenting the result. So if we are having some discrete points and we need to present it, uh, so PGF plot is one of the way. We have actually identified. So we begin with Pig's picture. We begin with axis. We are naming the axis. What is the level of the axis? It is time, and time in second. What is the x level? What is the y level? Y level is the frequency deviation in hertz. And then we are having a grid. We are segregating, or grid lines are highlighted in the figure. And then we are highlighting the point which we want to show through straight line. What are the different points? It is 0 0 is, so again, like 0 0 is the x coordinate and the y coordinate corresponding to this x axis and the y axis. 1 comma minus 2 is again like in the same way which we are doing, and 2 comma. So this completes the one of the very simplified figure which we can actually directly draw in our LaTeX file. So if there are like multiple figures, we can have different add plot coordinates. In same way, we are having in the previous, we have seen add plot coordinates. This is the bunch of coordinates that will be corresponding to a single waveform or single straight line diagram. If I have like two different a set of coordinates, we need to use add plot coordinates 2 times, with the first one corresponding to a different control action, different information, and second one corresponds to a different some other information, and then we can associate it. Legends generally, in particular, you would have seen how we actually present MATLAB data, if we are having multiple information in a single file, we use legends. So in similar way, we use legend here. So particularly the first one corresponds to conventional control and the second one corresponds to, so this is the way of highlighting uh, legend, like first one corresponds to control action one, second one corresponds to control action two, or case one, case two. Anyway, how you are going to present your information. But legends associated with the first information correspond to the facts first set of coordinates and second information corresponds to the second set of coordinates. Again, we have like gone through or highlighted many a times that the importance of a good picture. We actually need to convey or market the results which we have obtained through this analysis in the best possible way. So everything which we have discussed for the last like 1 hour and 20 minutes, it is like directed towards how to present our work in the best possible way. Now comes how do we actually use this AI methods to accelerate. So we have got some scientific ideas we can like use, or even we can ask for a better prompt from the GPT that provide me a prompt that I need to actually do this. So it will provide us a prompt, and then we can like convey the information to some other GPT models and come up with the results. So these are the ways of doing it. Like create a publication quadratic block diagram of a closed loop loop frequency control. So this is like one of a way of uh, asking this AI to come up with in a very quick way to come up with a result or come up with a code that help me in doing these things. Uh, there are actually ways which initially I have talked about that suppose I am going to create a question paper for circuit theory exam, and I have some circuit uh, that is in the back of my mind, some figure. So what I do is that there are two ways of doing it. One is the way of actually identifying the nodes and drawing the arrow, drawing inductor, drawing capacitor, and then the second and the easy way. So knowing the first way is important because if you go other way around, which I am going to say at this point of time, that what I will do is that I am going to draw the figure in a very clear way. I will take a snapshot and I will directly give that figure to the GPT. And then I will say that draw a TIGS file format for this figure, and I want to directly use it in overlay. It will provide me the corresponding code. It, most of the time it provides me, and most of the time it provides me in a correct way. Some of the time it so happens that if the figure is complex, or if you are using the free version, or if most of the time we are using the free version, you over limit it, or AI is not giving you a better result. Now that you are having the code, you need to know what sort of tweaks, what sort of modifications can I do so that I come up with the figure which I have given in the original one. The code given by the GPT is generating some distorted figure that is not 100% distorted, but it is like 80% distorted, 90%, 10% distorted, 15% distorted. How come I modify that figure? For that, you need to know the first-hand information that you actually have that precise information of TIGS environment. You know the nodes, you know the how to draw an arrow, you know how to place an inductor, how to highlight the inductor current at t minus 0 or t plus 0. You have that, you know where to write these things, and then the figure will be like in the way which I have expected it to. So using AI independently is not going to help any one of us, but knowing the background of the initial thing On top of that, using the AI is the best way, because at times there will be some tweaks you need to do to arrive at the result you would have expected the AI to have come up with, but somehow it doesn't come. Okay, so these are like some of the work I have highlighted, that can we like draw these things. uh, uh, Prompt idea is that convert this hand in drawing. I have drawn this figure on the page. I have now actually asked GPT to convert it into text code. Okay, and these are the additional commands to preserve the topology, labels, and relationship exactly. This is like we have actually seen the where we add two waveforms and we have used legends, and can we like, if we are having this figure and I want to actually generate this figure through LaTeX. However, if we can import this figure, there is a way of importing this figure. However, if I'm going to import this figure will be in the PNG or JPG format. The quality of the figure might be poor. Why not draw this figure in the vector form so that the quality is, this figure, the one you are seeing here, is in the vector format. Now, if you're going to zoom it, you will see that it is not getting pixelated. At this so much zoom, even there is no not pixelated, because this is a vector image. This is the beauty of vector image. Like even zooming it to 500%, it is not getting pixelated. Can we like directly draw? If you are having picture, take the snapshot of the picture, feed it into the GPT, ask to give me the text command. Okay, ask to give me the text command, it will give. Now, if the result is not what you expecting, then you should have that knowledge where I should uh, modify it such that my end result is what I need, what I would have, what I was expecting from the GPT. Okay, so when asking GPTs what is the best way, that the information should be like provided to the GPT in a very clear way, rather than giving the prompt as make a nice little diagram of a microgrid. Rather, you should give in a detailed way that draw a microgrid in which there are one wind turbine, there are two solar this, and wind turbine is of 1.5 megawatt. The solar is of like 400 kilowatt. There are two solar panel, and we are having one diesel generator of this rating. And we are having fuel cell, we are having battery, we are having some main controller that switches on and off with the main grid. Mm, Everything has to be, even the background color should be this, or the text should be written in Times New Roman or Arial or Calibre, or so what you need to expect from the GPT, write it to the GPT. It may happen that at the end you are not getting the result you were expected. Then you need to come up with, so that then your classical knowledge of this LaTeX is going to help you. So it is not that doing everything through GPT is going to help. Rather, it might create a chaos in your work. So knowing the theory and then using these generative AI models is the best uh, in the business. Okay, so these are some templates that can be like reusable. That has to be like kept in some notepad. You have some template. If it is giving a very good result, and use that template, modify the template, and then continue using that. Suppose I am trying to draw or create a file using, everything is same, but I want this file to be compiled using this ZLatex or PDF latex. Then the script will be slightly different if compiled to PDF latex. But now that I have a prompt, I can like modify in the compiler mode. I can use like PDF latex or ZLatex. So, or if I'm using the this same template, I want to draw the figure in landscape mode or portrait mode. Okay, so if you are having some template, just use that template and modify it. These are some quick ways of coming up with a solution. Now, the thing which I have highlighted in the previous few minutes earlier is that there might be some error. The generative AI might give you a code that produces a result or figure that is not up to the mark or that is not what you have expected. Then do not go for again like asking him to modify this like that certain feature is highlighted. There, it might happen that you highlight some certain feature, then some other feature is like distorted. Rather than uh, giving command to generative AI n number of times, if you have got like only 10% deviation from the mean, use your intelligence and identify in the script what should I modify such that I get the result I was expecting the generative AI to give me. You should actually have that knowledge. Okay, so these are like some of the checklists. There will be problems, the code AI given, there will be some problems. It might not compile it, or there will be some package clash or some package missing. So you actually need to do not blindly follow the results or the script given by the generative AI. Rather, use the intelligence and intellect the easiest way, the apart after knowing the know-how of these graphics command, TIGS command, the easiest way is to draw the picture or have a picture, take the snapshot and then feed in, take the code and then modify it. The most efficient way which I have actually come up with. These are like some small projects you can have after this presentation. You can work on these projects and I will be also sharing my email ID so that if some of you come up with an error or some of you need some further clarifications, we can uh, continue communicating through emails. So these are some of the work you can actually go through and come up with the result. So I have actually given the answer apart from giving the questions. This is the script corresponding to the figure. Okay, and what are the errors that creep into the system? You compile a text file and it will say that file, the name of the file not found. So there are problem is that actually the figure is not in the same folder where that text file is, or there is some uh, file name mistake in the form that figure with a small f and figure with capital F are read in a different way. They are read differently. There is some capitalization problem. Paths are different. Figure is in PNG format, but you have written it file figure.pdf not found. You have asked figure in PDF format. So there will be like some extension problem. So rather getting panicked over this figure file not found, it is better to revisit the folder and then look into where the error is happening. Figure is too large, file too large, or file too large, or rather the file will be displayed partially and partially it will be out of the page. So it is better to reduce the file size and then go for a better size that suits the page dimension. File is in the wrong location. File, okay, what happens is that since begin figure and end figure is a floating environment, so you have discussed the information related to figure on say page number 4, but the figure is either in page number 1 or in page number 7, because this is a floating. The LaTeX somehow compiled considering or working on minimization of those white spaces. It places figure in figure number on page number 1 or page number like 10. But you're discussing on the information related to that particular figure on figure number 4. So it happens that it might create a problem for the reader who is reading your article, that he is now to he has to like swap a large number of page either to the left or the right to come up with that figure. For that, we can use this HTTP. Even if HTTP is not working, we can use this capital H, forcing the figure to be on page number 4 or page number 3 or 5. But again, we have actually highlighted is that for corresponding to capital H, we need to actually use the corresponding package we have discussed, and we need to avoid excessive use of capital H, because that might lead to poor page break and white spaces in the end result of the compilation. TIGs, the most of the problem in TIGs or drawing circuits or flowcharts in LaTeX is that braces will be like mismatched. You have opened a curly braces, but you haven't closed it, or there are like some semicolons or colons that is needed, but you haven't actually properly used it. So most of the time it is a syntax error when using TIGs command. What are the best practice? Best practice is that if you are using a graphics command, that means if you are having a figure that is like previously extracted from internet, or you have extracted from book or paper, or if you have like some images, you directly use it. Use some meaningful file names. That means label it through some or if you are using suppose for example, if you are using if you are drawing a microgrid layout, then rather than writing figure as figure name as microgrid, we should write as layout underscore microgrid, such that by reading the file name, we are actually knowing that okay, this is the figure corresponding to layout. And then when providing the caption, again we need to be very much clear that layout of the microgrid under study. This is the caption. Label figure colon layout under microscope. So that means when I am going to refer it, then I am knowing that okay, this figure correspond to the layout of the microscope. So a judiciously and meaningful name, it actually avoids hard times, which often happens when we are writing a very long document. Then we like lots of figures, lots of equation, lots of referencing. Then at that point, this comes very handy. What sort of things we are referring to? What are the don'ts which we actually should avoid? So it is better to avoid those taking screenshots and using in the article, because the screenshot is will be saved in the PNG, and PNG associated with these pixelated format, and the quality of the image gets reduced. Rather, if it's possible to draw that image in a vector form, it is always intelligent to go for that. Excessive colors are avoided, because most of the time, the colors will be not will only be visible on the online version. But most of the time, we are having like black and white printers, and on when we are printing those documents, then actually we are not able to highlight the information which the author is trying to convey through different use of color. Okay. Um, it is not advisable to actually type figure numbers. Rather than typing the figure number, one should go for referencing it. That's because the figure number referencing automatically adjusts the figure number. avoid use of capital H everywhere. And the last one, which I've highlighted few minutes back, is that do not blindly copy AI generated scientific diagrams. These are some of the packages you will be needing to actually use the graphics package for inserting or scaling, rotating, or cropping, for figure placement, capital H, float, for caption customization, caption, subfigure, subcaption, to draw a figure, text or PGF plot for plotting, for text wrapping. Text wrapping is generally, if the caption is very large, it is always advisable to text wrap it into two lines. So wrap fig or rotating, and adjust box are some of the other packages you might use at some point. This is the complete workflow diagram, how to actually present the work. Hierarchy of the figure is this: external image, for placement, for caption, sub-figure diagram, everything like I have discussed or repeatedly highlighted few minutes back. These are the official documents. It is a good practice to go through these documents in free time, rather than actually following or taking help from internet. It is better to actually, because these are like very powerful documents. There are like lots of information that is contained in these official documents. Uh, and this is like one page cheat sheet, what exactly or what sort of script we will be mostly using. These are like um, some of the prompts which I have compiled at this point. These are some quiz. These will do what we have discussed in the previous 1 hour or close to 2 hours. These are why do we actually which package do we actually need when using external? We have highlighted it. What is the purpose of this language? What is the purpose of this capital H? Okay, so these are like some of the pieces, these are some of the answers. Final takeaways: generate, compile, verify, modify, finalize. If you are using these AI-based things, generate it, compile it, verify it, and if there is a deviation from what you were expecting and the end result, modify it and then finalize it. I hope that I was sufficiently slow and that everyone have got hold of something at the end of the presentation, because this is the last slide, and I thank you for your patience and your time. So I am all available for the questions if you have any.
Yes, anyone is having any queries or doubts, you may ask from sir. Okay, so I think there is no any queries, sir. So
Sir,
now
could you please share your PPT, sir?
Yes, I will be sharing. I will be I will be sending this slide to Dr. Saran, and Dr. Saran will like decide how to use this. Okay, and I will also be sharing the my email ID in the chat box.
okay, so thank you, sir. Now I am concluding the session. Thank you very much, Dr. Asim sir, for delivering such an enlightening and engaging lecture. Your valuable insights and practical experiences and thoughtful discussions have greatly enriched our understanding of the topic. On behalf of the organizing committee of ROTW 2026, I, Dr. Arvind Kumar Prajapati, and all the participants express our heartfelt gratitude to you. Once again, thank you very much, sir. We wish you good health, happiness, and continued success in all your future endeavors. Thank you, everyone. So we will meet tomorrow at 5 p.m. So now,
Thank you for your time.
thank you, sir.